Okay, brilliant. So yeah, I'm from Hyperbat. We're a maker of electrical vehicle battery packs. So we have some very complex processes. We have almost batteries that kind of have 16,000 line items. So there's a lot of data and a lot of process to control. So what I'm going to talk about today is how we use digital twinning of our manual processes within the manufacturing environments to give us opportunities, what challenges we face when we're implementing them, and hopefully how we look to grow in the future. So firstly, I'll talk about the opportunities of and the reasons why we use digital twinning. So it's all to do with our process optimization. So looking at capturing real-time data that we use from the shop floor to go forwards and move us from a reactive kind of solution-driven environment where we have a problem and we go and look and we go and fix it, to more of a proactive solution-driven business where we see problems arising before they actually cause a problem, and then we go and look at fixing the root causes. We also use it for virtual training. So some of the environments in our manufacturing facility can be quite hazardous when we're arming battery packs, especially environment. So we look at, instead of kind of when a person's first introduction to that environment is them actually doing the process, is doing the hazardous process, the first interaction we have is actually a virtual environment. So people can learn and not put themselves at risk by doing the process for the first time. And also we use it for preventative maintenance. So we use it to predict the lifetime of our tools and also predict any downtime that we may have from the number of cycles that has been used. Some challenges that we had when the digital twin in place is digital collection complexity. So human behavior is hard to capture and model. If you've got a machine, the machine knows what it's doing most of the time. You can capture that data and you can translate that into your digital twin quite easily. Natural resistance. So human behavior is to resist a bit of change. It can be quite a sensitive subject with people when you're going from an environment of people are going to kind of unmanaged on the shop floor to building their process to actually having quite a level of supervision and look at the data capture that they're generating. That's we're very careful around that and want to make that as open and as easy process as possible. We also face quite a few integration issues. Manual tools are often hard to integrate. They're dumb. They don't know what data they're capturing. Maybe they know the amount of cycles they've done, but they don't really, it's not really describing the process and the way it was done. It gives you an output. It gives you a yes or a no, or it gives you a value. It doesn't give you this process was done well, this process was done badly. So it gives you nothing to react against. And that's what we wanted to change. So for this, we looked at different solutions. So to look at towards the natural behavior of resistance to change, we looked at privacy and anonymity. So we used techniques like data aggregation, data masking, so we could still have a useful data set, a really useful data set for our digital twin, but not specifying individual kind of operators and team members where we would just be saying, you're doing the process badly. That's not what we wanted to achieve. We wanted to look at the process as a whole and say, the process is wrong. Here's how we can change the process. It's not about individual kind of singling out of people and saying, you're doing the process badly. That's not what we wanted to achieve. So legacy integration to digital twins. We looked at using IoT and edge devices and also a combination of sensors. These sensors allowed us to collect whatever we wanted, whenever we wanted. So on the shop floor, if we needed to collect temperature, we'd add a thermometer onto the station, and then we can integrate that into the twin to give us real-time data on what the temperature was at the station. Having the IoT and edge devices allowed us not to slow down the digital twin in any way, so we didn't have to slow down the model to accept data from external sources. It wasn't doing all the calculation. The calculation was done real time on the actual shop floor, and that was pushed into the digital twin. I've missed a slide. There we go. I knew it was somewhere. So the solution to modeling manual processes looks at data variance. So using different data distributions can help us model manual processes. So looking at a normal distribution is very useful for looking at cycle time variation. Humans aren't robots. They don't do everything in the same way every time. Excuse me. Let's take a drink of water, run out of breath. So using a normal distribution can really help us ingrain that natural variance into the data set. Data recycling is also very important. As we get more data, we're collecting from the shop floor, we're re-putting it back into our model. We're looking at, is a normal data distribution actually what we're seeing? Is it more of a Poisson data distribution when we're actually seeing the real-time data of the process on the shop floor? And now look at the future, how we want to change things, how we want to go further. So augmented working, we want to look at using the virtual environment. Again, pushing more training. So people, again, the first time with the process is in the virtual environment. Motion efficiency, looking at people's motion and how we can improve that for ergonomics and safety concerns. And also dynamic workload management. So looking at the digital twin and whether when people do a process well, can we plan that into using their work all the time? So people who do a process better than other people can be given that process more often. Thank you very much. Happy for any questions at the end. Thank you.
So there's a question for both of you, actually, that is right at the top there. So to what extent do you use standardized terms? So as you can read, glossary controlled vocabulary ontologies in the design of your digital twin work, and where do you get these terms from? A very loaded question. Thanks, Jess. That's a great question. Jessica Simmons there, Visioning Lab.
Probably at the different end of the spectrum. So because our data, kind of like I mentioned, can be quite emotive, and it can be personal, as it can be seen as personal. We try to anonymize it as much as possible. It's very important to get human buy-in. So having an ontology that allows for a really firm standardized semantic layer is really key for us. So that's kind of that's the kind of ontology we've used, is really strong on semantics and being able to have human readable data so that we can engage people really early on with the data that we're capturing, the data that we're using, why we're capturing it and why we're using it. So, yeah.
And while we're at it, Nick, how do you differentiate between your different sources of data variance? I was coming from a point of, you've got humans in the loop, but you've also got how you're measuring, what you're measuring with, how often you're measuring, all those sorts of sources of data variance that you could bring in to try and create a clear picture.
Absolutely. And that's where the data recycling is really important. So yeah, we almost, because it starts off not as a digital twin almost, it starts off as a simulation in a kind of lockdown environment. And as we progress through building a product, we learn more and more about the product and more about the process. So that's where we go from kind of having a standalone simulation of the process, saying we deviate by a second every 3 sigma or something like that, whereas in reality we actually deviate a lot less than that. So it's very interesting, that data recyclability of looking at the variance that comes in with the data is then incorporated into the digital twin, so we understand that our variance is accurate, because there will be variance.
Okay. So you're in effect, you're kind of building this system out each time for each product, and you're almost refining, and like Michelangelo and his statues, you're getting more and more detailed as you go through, so that you can kind of validate as you go. Is that right?
Yeah, hopefully closer and closer to real life with the more we learn about everything.
But over to Nick. We've got time for probably 1 or 2 more questions. When assessing your processes for optimization, how much operational life data are you able to bring in? You can read the rest of it.
It's a fantastic question, and at the moment it's limited, which is a shame. Kind of as mentioned there, we do get kind of feedback from defects within the factory and some defects after shipping, but very little in terms of the life of the product. And hopefully there's some EU regulation that's coming in 2027 about digital product passports, which will hopefully drive a need for that understanding of the life cycle of a battery. So there are solutions out there where we can take real life data and real world data from the vehicle being on the road and use that back into our processes. But that's where another area for the future to expand.